Hello students, welcome to Unit 9 Notes, Section 1.9. This is the first set of notes in our Unit 9 packet. The packet is over 50 pages, it's about 50 pages long, so please, if you don't want to print it out, you don't have to, just follow along. I will be uploading this to the website when it's all done. So again, just follow along and take notes in a separate notebook if that's easier for you. But feel free to print it out if you would like. So I did the warm up. You can pause the video at this moment, and you can review all of your warm up. But it's just the distance formula. So I do want to go over something real quick. In this packet above, you have this SAT reference sheet. So these are the actual formulas in the SAT that you won't get the opportunity to take this year if you're a sophomore or junior, the PSAT and SAT. But these are the formulas that would be on it. I added a few other ones to follow along with. Just another heads up, here is your assignment sheet. So we have 7 lessons pretty much with a quick video for each, and then you have your corresponding IXL assignments that you'll have to complete. Notice this one assignment here. You'll have to upload to Google Classroom because there is no IXL assignment for it. And you will also have this updated schedule. So 2 lessons a week, watch 1 and 2, and then do 2 IXLs. Now you can do the practice in this packet as well. That will help prepare you for the test, but the IXL assignments are the ones that are graded. So 4 are due in a week, 4 are due the next Thursday, 4 again the Thursday after. Well, 3 of them along with the notes, and then 4, and then this week is a testing week. So it's just a test, review, and test, no IXL. All right. If you have any questions, you can ask me in the Google Live Meet that we have. So let's begin with our notes. We are beginning with perimeter and area of 2-dimensional figures. So we are going to find perimeters of rectangles and squares and circles. Here are your area formulas, your perimeter formulas and area formulas. You have, I like to call area of a rectangle and of a rectangle and a square as base times height. Let's keep it simple. They're both the same thing. A square has bases that are the same length, but as their height, but we're just going to call it base times height. And then you have the area of a circle, which is pi r squared. Now circumference is 2 pi r or pi d because there's 2 radiuses in one diameter. So multiply it twice, or just do the diameter times pi, which will give you your circumference. What that means is that if we take this diameter right here, it actually goes around the circle about a little bit more than 3 times. So if I were to let's say that was a string and I just wrapped it around, it would go around once, twice, 3.141. So pi is about 3.141 or 3.14159 as an approximation. So that's all that means. That's it for that slide. So let's do our first one. Here we have a pool that is 15 feet wide by 20 feet long, and we have a 3-foot surrounding of concrete. So we want to know how much fence to build around the deck of this pool. So we're not going to, what we need to do is we need to add the 3 feet here to both sides. So really, if this whole thing is 20, this edge is actually 26 feet because it's 3 plus 3 plus 20. Same thing with this. 15 is really 15 plus 3 plus 3, so it's 21 feet. So if I want to know how much fencing I need, that's going to be perimeter. So I'm going to do 26 plus 26 plus 21 plus 21 So that's 80, 612, oh, I'm sorry, 80, 612, that's 94 feet. So we're going to need 94 feet of fencing. Okay. A couple ways to find it. You could have just done 26 plus 21 and multiplied that by 2 because you have two of them. You have two lengths and two widths. Okay, so next one, suppose you want to find a frame of a picture that is 6 by 7 with a 1/2 inch with a 1/2 inch wide frame. Suppose you want to find a frame of a picture. Oh, you want to frame a picture that is 6 by 7 with a 1/2 inch wide frame. Find the perimeter of the picture. So that is going to be, the perimeter of the picture is 6 plus 6 plus 7 plus 7. So 6, 12, 18, 24, 25, 26 inches. And now you want to know the perimeter of the outside edge of the frame. So let's think about, you have your picture. You have a picture, right? So 6 by 7. But then you have a picture frame. Oops. We have a picture, and then we also have a frame around it. So this is a 1/2 inch. So if this is 6, then this 1/2 inch happens twice. So it's actually going to be, whoops, it's actually going to be 7 inches because it's 6 and then it's a 1/2 inch with another 1/2 inch. And the same thing is going to happen for the width of it. So if the width is 7, or height, whatever we want to call it, 7 inches, then the whole height is going to be 8 inches. So by adding that distance twice, we're actually doing 7 plus 7 plus 8 plus 8, which is 14, 20, 28, 29, 30 inches. So the perimeter here is 30 inches around the edge of the frame. So notice we actually added a 1/2 inch 4 separate times, and that gave us we did give me 1 second. We actually added it 8 times because in theory, we added a 1/2 inch here and a 1/2 inch here, a 1/2 inch here, a 1/2 inch here, 1/2 inch here and here, and a 1/2 inch here and here. So I'm sorry, 8 times, which is why we got the extra 4 inches. Okay, finding circumference. Find the circumference of circle A in terms of pi, and then find the circumference to the nearest tenth. So in terms of pi is what we call an exact value, where this is the nearest tenth is approximate. And you guys are familiar with that when we were using radicals. So here we have, we want to know the circumference. So remember, circumference is one of two equations. You can use 2 pi r, or you could use pi d, which is 2 radiuses is 1 diameter. So it looks like I have a diameter here. So I have a diameter of 12. So I'm just going to say circumference then is 12 pi inches. So it's my exact value. That's in terms of pi. And then I also have circumference. I'm going to type in 12 pi to my calculator, and I get 37. I get about 30. It wants me to the nearest tenth. So 37.69 is 37 whoops, 37, oh my, what am I doing? 37.7. And the way we get that is when we type in the calculator, it was about 37.69911. And that rounds to the nearest tenth. So we're going to focus the 9 on raising the 6 up to a 7. Okay, that's it. Let's change this so that it's a different color. There we go. All right. Find the circumference of the circle with a radius of 18 meters in terms of pi. So here we're going to do the circumference of a circle with radius. So circumference equals 2 pi r. So circumference equals 2 pi. The radius is 18 meters. So circumference then equals 36 pi meters. And find the circumference of a circle with diameter of 18 meters to the nearest tenth. So this one is circumference is what did it say? A diameter of 18. So circumference is pi d. So circumference is pi times 18 meters. So circumference equals 18 pi meters. And what we need to do is 18 pi circumference approximately equals 56.548667. Okay, so circumference approximately equals 56.5 because the 4 rounds off. Okay, so that's the nearest tenth. All right, next problem. So here we're going to find the perimeter. And what's tough about this one, well, it's not tough. It's it has a diagonal, and we need to know the length of that diagonal. So find the perimeter, yeah, and then find its area. So here's the first thing I'm going to do. I'm going to label this. Whoops. Let me change the color. It's hard to see on here. So this length here is 1, 2, 3, 4, 5, 6 units. It goes from -1 to 5, so I know that that's 6 units. And I know that this one goes from 6 to -2, which makes it 8 units. Okay, so it's, yep, and I count them just to double check. 1, 2, 3, 4, 5, 6, 7, 8. So now you can do the distance formula, which is why this started off as a warm-up with the distance formula, but remember, you can also do the Pythagorean theorem. So I find the Pythagorean theorem just a little bit easier, so I'm just going to do L squared plus L squared equals H squared. And I think my values were 6 and 8 for my legs. And I can only use the Pythagorean theorem when I have a right triangle, which I have a right triangle. So that's how I knew that this had to be the hypotenuse right here. So 36 plus 64 equals H squared. 100 equals H squared. The square root of 100 equals the square root of H squared. 10 plus or minus 10 equals H. Ignore the plus or minus because it can only be a length that's positive. So we get H equals 10. So if you noticed, it's a 3, 4, 5 triangle, right? It's a Pythagorean triple. 3, 4, 5, 6, 8, 10, 9, 12, 15, any multiple. Take 3, 4, and 5 and multiply it by any number, and you get a Pythagorean triple. So now we need to find the perimeter. So we did all that legwork here, and I'm going to now do the perimeter. So perimeter equals 6 plus 8 plus 10. So perimeter equals 18, 19, 24 units. We don't know if it's inches, feet, yards. It doesn't matter. It's on a coordinate plane, so we're going to just use the term units. It's important we label this whole unit, literally the unit 9, we want to label with units. Whether it's units, units squared, inches, inches squared, yards, yards squared, feet, feet squared, anything like that. Okay? Area now of a triangle. Area is 1/2 base times height. So area equals 1/2. The base is 6 and the height is 8. You can interchange those. 8 and 6 don't matter. You can interchange them. It's only multiplication. The base visually, though, looks like it is 6. So 6 times 8 is 48. Half of 48 is 24. So area is equal to 24 units squared. Remember, it's area, so it's squared units. Why? Because we did 6 times 8. We did 6 units times 8 units. So units times units is units squared. Okay. All right. Next one, quadrilateral. Quadrilateral. KLMN, where K has -3, -3. So -3, -3 is right there. We have 1, -3, so 1, -3. We have M is 1, 4, and we have -3, 1. -3, I'm going to make sure I did everything right. Okay. We want to find the perimeter, and we also want to find the area. Now, I'm not going to show you yet how to do the area of a trapezoid. You might already know, so you can do it differently if you want to. But right now, I'm going to find the length of the distance around, which is the perimeter. So this appears to be, let's see, this appears to be 2, 4, 6, 7 units. This appears to be 4 units. This appears to be 4 units. And this is going to be 5 units. And the reason why I know is because I'm going to do the Pythagorean theorem. And look at how I split this up, okay? So this is a 4 because this is 4 because this is 4. If this is 4 and this is 4, but this whole thing is 7, then 7 minus 4 is 3. So if I want to, I don't want to write a 3 there unless I break this into 4 and 3. And that's fine. Break your 7 into 4 and 3 so that you don't double dip on those numbers. You remember that side's only 7. It's not 7 and 3. It's 4 and 3. So if I did the Pythagorean theorem off to the side here, you would get L squared plus L squared equals H squared. So 3 squared plus 4 squared equals, sorry, writing fast. 4 squared equals H squared. 9 plus 16 equals H squared. 25 equals H squared. Square root of 25 equals square root of H squared. So 5 equals H. You probably already knew that the hypotenuse was that if you remembered your your Pythagorean triples. So perimeter is going to be 4 plus 4 plus 4 plus 3 plus 5. My suggestion, start somewhere, 4, 4, 4, 3, 5, and go all the way around. 4, 8, 12, 13, 14, 15, so perimeter is 20 units. And now we want to find the area. So this is going to be what we call a composite. So I'm going to first find the area of a triangle. Now again, you might know the area of a trapezoid, and that's fine. But, whoops, base times height. But I'm going to do this separately. So area of the triangle is 1/2 4 times 3. So area of my triangle is 1/2 of 4. So 2 times 3 is 6. So 6 units. And then what I'm going to do is I'm going to do the area of that square. You can call it square or rectangle because it doesn't really matter. They both have the same formula. Area of the square is base times height. Area of square is 4 times 4. Area of square is 16 units. So area total is 6, equals 6 plus 16, which is 16, 17, 18, 19, 20, 21, 22. I'm going to write it one more time. So area total equals 22 units squared. Let me fix my units. That's supposed to be units squared. That one's supposed to be units squared. And then I'm doing 6 and 16 units squared. And there we go. Okay. All right. Not too bad. You should have already done some of this in middle school, but now we're going to be focusing more on the combining of the parts to it. Okay. Here we have a banner, and it's displayed at a museum. Okay. It is 4 feet wide and 7 yards high. And the first thing you want to do is 4 times 7, but you need to hold on and make sure that you focus in on the units here. We can't mix our yards and our feet the way we want them to when we multiply them. We have nothing called a foot yard. So we have to make sure that we convert. So I'm going to say that 7 yards, there are 3 feet in a yard times 3. So I'm going to say there are 3 feet in 1 yard. Here's how we convert. Ready? So I have 7 yards, and I say that there are 3 feet per 1 yard. So here's what happens. Yards divided by yards goes away, and I have 21 feet. 21 feet over no yards, okay? So this is now 21 feet. So now what we're going to do is we are going to find the area. We're going to do 21 feet times 4 feet. So area is going to be 84 feet squared. Now I can answer that question in that way, right? 84 feet squared is an answer. It's a good answer. It's just as good as another answer I could give. So I can give this answer in yards as well. Now here's what's important. There are not 3 feet in a yard. I'm sorry, there are not 3 feet in a yard squared. There are 3 feet in a yard. So if I want to go from feet squared to yard squared, I can't just divide by 3. I have to divide by 9. So think about, if we have think about 1 yard by 1 yard notice it's made up of 3 feet by 3 feet. So it's really 1 yard squared is equal to 9 feet squared. So we just have to be careful. So if we're going to give, oh, you know what? Look at this. There we go. This is actually the second question. Find the area of the banner by first changing all units to yards. Well, we could, change all of it to yards, or what I can just do simply, I'm going to do 84 feet. So I'm going to say the area is 84 feet squared. There is, to convert to yards squared, there are 9 feet in a yard. I don't want to make this more complicated here. Why don't I just erase that? Just divide this by 9, and now you'll have yards. So 84 divided by 9 is about 9 1/3. So it's 9 1/3 yards squared. So the area is now 9 1/3 yards squared. Get 9.33. Okay. Now check this out. If I did convert this, 4 feet, that's 1 1/3 yards, right? So 1 1/3 times 7 is what you would have done. So you've done 1.33 times 7, and you get 9.33. So it's the same thing, okay? All right, next one. The diameter of a circle is 10. Find the area. This is a multi-step problem, so you're going to have to do the first thing to find area. Area is pi r squared. Circumference is 2 pi r, or circumference equals pi d. Now notice that circumference has 2 formulas, but only one of them has r in it. So these are the 2 that we're going to need to use, and the reason being is because they both have r. So once I solve for an r, I can interchange them. Okay, so we're going to stay away from this one, this formula we're not going to use. So circumference equals, oh, you know what? The diameter is 10. You know what? We can use this one. But really, we want to solve for r. Oh, you know what? The diameter of a circle. Okay, we didn't have to go that far. I'm sorry, I misread this question. So there are 2 radii, radiuses, plural is radii, spelled with 2 i's. 2 radii equals 1 diameter. So if the diameter is, so 1 radius is equal to a half a diameter. If I divide both sides by 2, right? So if the diameter is 10, half of 10 is 5 inches. So the radius is 5. So if the radius is 5, I can now find the area. So area equals pi r squared. So area equals pi 5 inches squared. 5 times 5 is 25. Inches times inches is inches squared. Don't forget your pi. We're leaving it in terms of pi, and we are good to go. Okay? I'm sorry, when I misread this, I thought it said the circumference was given. So if the circumference is given, you have to work backwards, and you have to solve for r. But that's not something that we needed to do. Okay? The diameter of a circle is 5 feet now. Okay, so we're going to have to find half of 5. So 5 feet divided by 2 is 2.5 feet. Often, often we won't leave pi with a decimal. I mean, we do sometimes. So I'm going to write this pretty much two different ways. We can leave it as 5/2 feet, or we can leave it as 2.5 feet. So here are my area formulas. So area is pi r squared. So it's going to be area is 2.5 feet squared. Or I could write it like this, 5/2 feet squared. So now I have 2.5 squared is going to be 6.25. So that's 6.25 pi feet squared. But if I do this fraction, it leaves it as 5 times 5 is 25, 2 times 2 is 4, so 25 pi over 4 feet squared. So either of these answers is correct. Normally, like I said, you don't often see a decimal, but you can. I mean, there's probably sometimes some people out there that say it's not okay to do. It is in terms of pi, and that's what we wanted. So, and then let's approximate it. Either way, if I do 25 pi divided by 4 in my calculator, I get 19.63. If I do 6.25 pi, I get 19.63. I get the same thing, rounding to the nearest tenth. So I'm going to say area approximately equals 19.634954. So area approximately equals 19.6 to the nearest tenth. And it's feet squared. Okay? And that is it for that one. Next one, we have an irregular figure here. So if you were in class, I'd ask you to come up with a bunch of different ways to solve this. So some students would break this up like this. Great, that's a great strategy. Some students would break it up like this, and they would make rectangles and squares. Okay, great strategy as well. Some students would break it up like this. Huh, cool. Absolutely. I think that's a great way to break it up. Other students would do this. They would find the area of everything as if it was a square, and then they would take away from it the piece, then they would take away this area. That's also another strategy. There's so many ways to solve this. It doesn't matter. They'll all be right as long as you do the right math. So let's break it up this way, because it looks like all these pieces are 2, making all these pieces 2. Okay, so it looks like it's going to be a 2 by 2, which is 4 centimeters squared. So 4 centimeters squared. So 4 centimeters squared, and this happens a few times. So it looks like it happens 3, 4, 5, 6 times. So we have 4 centimeters squared times 6 squares, which is 24 centimeters squared, which is the answer to B. Okay, so again, you could have broken that up into bigger rectangles and a square if you wanted, and that would have been fine too. All right, we're close to being done. Now this one says find the area and perimeter of each figure, and it says this is from section 10.1. So in 10.1, it's going to come back and ask us the same question, so we'll probably skip it by the time we get there. If it's easy to do. So now again, you don't know how to find the area of a, I haven't showed you how to find a parallelogram, and I haven't showed you how to find a trapezoid. So let's break this up a little bit and just find out what these areas are. So here we have, let's break it up this way, okay? And let's break that one up that way. Let's just do a whole bunch of triangles, okay? And that one square that we see. So this square is 3 by 3, so this square is going to be 9, okay? This one is 2, every one of these smaller triangles are the same. So here we have area equals 3 times 3, which is 9. Then we have a smaller triangle. I'm going to say area equals 1/2 base times height. So it's 2 times 3, which is going to be equal to half of 2 is 1 times 3 is 3. So this one's 3, 3, 3, and 3. And looks like we have this other triangle. So this other triangle is 1/2 base times height. Here is its base, 1, 2, 3, 4 units. 4 units. Its height is perpendicular, 1, 2, 3 units. So it's going to be half of 12, which is 6. This one's 6. You could have even broken it up more. You could have broken up into 2 of those same triangles that we have over here that I did for the rest of these. Okay. So now what I want to do, I don't want to leave them separated, right? I mean, I guess I could. Or I could combine these 3 to be 3, 9, and 3. So this collectively, this parallelogram here is 3 and 3 is 6 plus 9 is 15. But you know what? Let's just leave it. Let's leave it separate. Yeah, let's just leave it separate. It'll help us solve it. So the perimeter ones. Let me do this first. Let me label it 3 units squared. Okay, just so we know we're dealing with square units. Okay, and this one I'm going to do 9 units squared. And then this one I'm going to need, it's going to have to be, what did we say? It was 6 units squared, right? Yep. Okay, the only other things that we need to do, notice this. When we're going to find when we want to find the perimeter, these are easy to find. These are all linear. These are all linear. These are linear, but they're on a diagonal. So we need to do the Pythagorean theorem to find it. But here's what's really cool, everyone. This is equivalent to this, is equivalent to this, is equivalent to this one. So they're all equivalent. So it's actually only one formula we need to use for that. So I'm going to say, let's do running out of colors here. Let me do, nope, I did orange. I did blue. I didn't do blue yet. So L squared plus L squared equals H squared. So we have 2 by 3. So I have 2 by 3. These are all 3 by 2, 3 by 2. They're all 2 by 3. So I'm going to do 2 squared plus 3 squared equals H squared. 4 plus 9 equals H squared. 13 equals H squared. Square root of 13 equals square root of H squared. H equals square root of 13. So this is the square root of 13 units. I'm going to do square root of 13u, square root of 13u, square root of 13u. So be careful, do not mix up the units with the unit squared, okay? We also have, uh, other than those, I'm not going to label anything, okay? Because we don't really know what we're looking for yet. So that's my suggestion, is to do all this work first, and then you can solve all of these problems quite quickly, okay? So the first one is ABJF. So parallelogram ABJF, okay? Well, that's the area is going to be the area. Well, let's do, what color did I use? Maroon, okay. So, well, let's do perimeter. What does it ask me first? Perimeter. So perimeter is square root of 13 plus, so square root of 13 plus 1, 2, 3, 4, 5. So it's that twice. So it's 5 plus the square root of 13 plus 5. So the perimeter is, perimeter equals 10 plus 2 square root of 13. Be careful, you do not want to, 5 plus 5 is 10. Square root of 13 plus the square root of 13 is not the square root of 26. They are items that you're adding together. There are two of them, okay? They are 2 times the square root of 13, like 2 times 5 is 10. Okay, the area now for this one is going to be, area is base times height, and that is, well, we have a height of 3, and we have a width of 5. So it's going to be 5 times 3, so area is 15 units squared. Whoops, I messed up because I didn't label my units on my last one. Do as I say, not as I do. Throw on units. You only need to use the word once. Okay. The next one, BDJ, is a triangle. So BDJ is this triangle here. Okay. So it's 2, 4 plus the square root of 13 plus the square root of 13. So without showing my work, because I don't have much room, it's 4 plus 2 square roots of 13 units. And when you write radicals, you tend to put the whole numbers first. So 4 would come first in this case. And then now area is, units squared, but let's see. It's 4 times, it's half of 4 times 3. So half of 4 times 3. So area is 6 units squared. All right. Okay, DKJ is, the same exact triangle, but flipped. So guess what? I am going to copy and paste all of these items there. Okay, same triangle, but flipped. Then we have, okay, and then we have triangle B, sorry, B, D, K, J. So it's this one right here. So it's 1, 2, 3, 4. So we have a perimeter. It's 4 and 4 and square root of 13 and square root of 13. So it's going to be 8 square roots of 13. So we're going to have 8 square roots of 13. Okay. 8 plus 2, sorry, 8 plus 2 square roots of 13. Then the area is, base times height. So it's 4 times, has a height of 3. Here's its height right here. It's a height of 3. This is what we call an altitude. So it's got 3. Oh, I'm sorry. You know what? At this time, you don't know. I haven't told you. how to find the area of a parallelogram. It's actually base times height, but let's not do that. Let's just add up the areas we already have. We have 3 and 3 and 6. We already did the work for it. So 3 plus 3 plus 6. So area is 3 plus 3 plus 6, which is 12. It's 12 units squared. Okay, 3 more. ADKF. ADKF is the entire thing. Wow, okay. ADKF is the entire thing. So we are going to, I'll just copy something like that. So the perimeter is definitely 2 square roots of 13, but it's also 1, 2, 3, 4, 2, 4, 6, 8, 9, and 9 is 18. So it's 9 plus 9 is 18. So the only difference is that that is 18. Ugh. Come on, come on. Yep, there we go. I'm being lazy. All right, 18. And then the area is going to be all these things together. 3, 9, 3, 3, 3, 6. 3, 9, 3, 3, 3, 6. Three, 9, 3, 3, 3, 6. So 3, 6, 9, 12, 15, 18, 27, I believe. 27 units squared. All right, triangle BCJ. BCJ is 2, let me see. It's a smaller triangle. So it has, it looks like 2 plus 3 is 5. So 5 plus the square root of 13, just 1 square root of 13. So its perimeter is 5 plus square root of 13. And I got that from here. 2 plus 3 plus square root of 13. And then it looks like it's half of 2 times 3. So half of 2 times 3, whoops. Half of 2 times 3, so half of 6 is 3 units squared. The last one, ADJF. ADJF. Okay, so this one, okay, let's look. ADJF is this trapezoid. Again, you don't know the area of a trapezoid yet. So I'm just going to do a perimeter, and it's going to be an area. That one will work. Okay, perimeter is 2 square roots of 13 because we have one right here and we have one right here. We also have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's 14 plus 2 square roots of 13, sorry. And then its area is 39333, right? 39333. There's so many ways to find it. You could have taken away from the whole thing. 39333. So we have, wait, 39333. I just want to make sure. 9, 18, 19, 20, 21. Okay. All right, one last problem, and then we'll be going. I'll let you get started on the homework, which is these. Remember, you don't have to pass them in, but they'll help you for your test that you have to take. Okay. But again, only IXL assignments are being graded for completion for classwork. So here we have Anne that drew these 3 figures on a graph. I'm sorry, that's supposed to say graph. A fly lands at random at a point on the grid. Oh, you know what? Maybe it was supposed to say grid, not grad. Grid. Is the fly more likely to land on one of the figures or on the blank grid? So, explain. Well, to save time, I'm going to do the work for you, okay? So this one has an area of, ready for this, 3 and then 2 and 4. Its area is 4 times 3, which is 12 units squared. This one also has an area of 12 units squared. Base times height. What you'll realize in the next lesson is that this right here is actually its height. It's called an altitude, and that's its base. So 4 times 3 is 12. But I did that work in my head so that we didn't have to. And then we have this one, which is, let's see, half of 2, 4, 6, 8. 8 times 3. I did 3. Let me just do it. 2, 4, 6, 8. Yeah, so half of 8 times 3. 8 times 3 is 24. Half is 12 units squared. So guess what? Is a fly more likely to land on one of the figures or on the entire blank grid? Well, the figures, so the area of the figures is equal to 36 units squared. 12 plus 12 plus 12. Let's take a look at the whole grid. The grid is, let's see, 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 2, 4, 6. It's 20 by 6. So 20 times 6 is 120 units squared. So think about, I think it's pretty self-explanatory at this moment that it's going to land on the grid more often than it's going to land on any of these shapes or them combined. But how do we find that? We do the area of the grid, take away the area of the figures, and that will give me the area of, you know what? Let's say, well, the grid, when I'm talking about this grid, I'm talking about the whole thing. I'm talking about everything that's possible. Let's say the area not shaded on grid. Let's call it not shaded on grid. So it's the blank grid. Oh, you know what? Let's call it blank grid. Where this grid word will stand for a total grid, and this one will be our blank grid. So we have 120 take away 36 equals 120 take away 36 is 84. So the area of the blank grid is 84 units squared. So the way to determine the probability or which one's more likely, well, we see that there's just more area, so it's going to be more likely. But if you want a percentage, you could even do that. You would just do, quickly, you would do 36 over 120, which is 30% of the time. And you would do 84 over 120, which is 70% of the time. Okay. Is the fly more likely to land? So we're going to say on grid, on blank grid. I don't really have room to answer why other than the work that we already used to explain. So let's keep it mathematical and not verbal. Suppose you know the fly lands on one of the figures. Is the fly more likely to land on one figure than more than landing on another? And the answer is no, they all have the same area. No, they all have the same area. And the last one, which figure has the greatest perimeter? I'm getting sloppy. Okay, which figure has the greatest perimeter? Well, I'm going to do this work as well, okay? Just bear with me real quick. So this one's going to be 3, so 9, that's the square root of 10, and this is 1, 2, 3, 4, okay? This one is 3 by, so this one is 3 by 4, 3 by 4, and this one is, I'm going to do this math in my head, it's going to be 2, 4, 6, 8, okay? So that's 7, 49, 49 and 1, 2, 3, 49 and 9. 49 and 9 is 58. So that's the square root of 58. And then that's square root of 10. Okay, so just ignore how I got them. I'm just trying to save time here. The point is, I used the Pythagorean theorem in my head to figure it out. So here we have 3 plus 4 plus 3 plus 4, which is 4, 8, 9, 10, 11, 12, 13, 14 units in blue. So perimeter of rectangle. Then we have perimeter of, that is a parallelogram, which is 4 plus 4 plus the square root of 10 plus the square root of 10, which approximately equals, and so 4 plus 4 plus the square root of 10 plus the square root of 10. Oh, I messed that up. I accidentally put the square root of 10 under the radical of 10. Okay, this one's about 14.32. And then the perimeter of my triangle is 8 plus the square root of 54. Wait, 8 plus the square root of 58 plus the square root of 10, which approximately equals 8 plus the square root of 58 plus the square root of 10. I did it again. Is about 18.78. So what we see is that the more we manipulate the figure from its original standing as a rectangle or square, the perimeter will get larger. So this one has the greatest perimeter. And there we are. So you are good to go. I'm sorry this lesson was so long, but I tried to make it as quick as possible. Watch it. Watch this one and other ones on speed on YouTube if you would like to get through them faster. So you can start that, and don't forget you have IXL assignments that go with this. Okay, good luck.